Welcome to a geometric conjecture. Here we render the first, second and third generation particles. And to avoid unnecessary complication, we only need utilize master map 1, whereby we discern zone 1, analogous to the neutral Z boson, and zones 2 and 3, each analogous to the charged W bosons. We call the composite electron down quark and up quark, coloring them green, blue and orange for visual clarity. And we discern the composite electron in positions 1, 2, 3, 4, 5, 6, and back to 1, rendering each of its 4 components as the right chiral electron, the left chiral anti-electron, the right chiral anti-electron, and the left chiral electron. And its relative mass is rendered utilizing the right chiral component and associated F1 knot, recalling its speculative ties with the neutrino and other 3 components, each color representing a weight such that they sum to 33. In similar fashion, the relative mass of the down quark renders such that the sum of the weights is 31. Likewise, the relative mass of the up quark renders, only this time the pattern changes such that we sum positions 1 and 4 component weights, or 2 lots of 27 plus 94 and 6, giving us 154. And we'll save the details of relative orders of magnitude for another video, thereby explaining the 54 in lieu of the required 154 for the up quark. And although such pattern degeneration may be disconcerting, it conditions us to nature's a priori of never standing still. For nature is an abstraction from mathematics, manifesting eventfully. This is best evidenced by way of example, so keep the pause button close by. We establish the weight of each knot by comparing its code to all 729 knots in the map, assigning a particular color for that weight. The nest weight being the sum of the 9 knots housed in that nest. If we now recalibrate each weight by comparing each code only to those 81 knots in the same trunk, then we establish the new gray shaded nest weights. And depending on the functionality, we may assign a dark gray color for a nest weight of 9, or no color at all for a nest weight of 1. From this, we find 2 pairs of parameters defining the fine structure constant. And we'll save the finer details for another video, else this one be unwieldy. Suffice to say here that the pair of parameters 29 and 137, and the pair 31 and 128, give these conjectured exact FSC values, differing from the recommended codata range by just 10 to the power of minus 12. We'll now juxtapose our first generation particles in position 1, coloring them green, blue and orange for visual clarity. And with our speculated neutrinos in this position, we see a synonymous pattern of behavior with our second generation, muon, strange quark, and charm quark. Also observing the muon in these adjacent nests, such that we morph into the third generation tau particle, whereby these adjacent nests in position 1 and 4 combine to render the bottom quark, while the top quark renders like so. We'll pause here to concede that a wide audience is required to ponder and critique this symphony of synonymous patterns. These choicest ones simply fit nicely in this finite space, allowing us some sense of what constitutes each particle. Yet we'll reward ourselves by continuing, as we may imagine our bottom quark rendering in this fashion, or this, with our top quark rendering here, and maybe our bottom quark here. From this position, it isn't hard to imagine our second generation muon like this, or like this, with our strange quark like this, and our charm quark like this. Or perhaps we want our charm quark here, our bottom quark here, and our electron here. Or perhaps our charm quark here, our bottom quark here, and our electron here. Or our top quark, electron, down quark, bottom quark, up quark, here or there. Therein begs a question of interest. A wide audience is required to critique and ponder, and although critiques are welcomed, criticisms dismissing these correlations as being non-causal or mere coincidence are missing the point, for it is nature itself that is begging the question, apparently whispering something in these maps. All we need do is listen.